8.3, similar polygons. Now, in the previous section, we already went over the idea of a similar figure, and we said that figures are similar if a similarity transformation exists that maps the first figure onto the second figure. So if we look at our images here, we have ABC, which is mapped by a similarity transformation to DEF, so we know they're similar. Now, corresponding parts of similar polygons. So if figures are similar, then we have two things. First of all, corresponding angles are congruent. And remember, congruent means equal, and specifically here, I'm talking about the angles. So I could say that angle C is congruent or the same exact measure to angle F. We can say angle B is congruent to angle E, and we can say that angle A is congruent to angle D. So they have the same exact measures. And number two, corresponding sides are proportional. Now, what we mean by proportional is that essentially we're going to find our scale factor. So KC, or the ratio of KC over his corresponding side C, is going to be equal to KA over A, which is also equal to KB over B, which ultimately is equal to K, which is our scale factor. Those are the two things we know about the corresponding parts of similar polygons. Example 1. In the diagram, triangle RST is similar, and if we haven't got that one yet, the little squiggly means similar to triangle XYZ. So they're telling us that they're similar, and then just make that a T up there. Part A, find the scale factor from triangle RST to XYZ. Now again, pay attention to order here. They said RST to XYZ, meaning RST is the pre-image and XYZ is the image. So if I want the scale factor, I have to find, for example, 12, which corresponds to 20, and we're going to take 12 over 20. You don't have to pick those. You could have picked 18 and 30. You could have picked 15 and 25. It doesn't matter, because if they're similar, they should all be the same. If we simplify this by 4, that's going to give us 3/5. So our scale factor is a reduction by 3/5. Part B, list all the pairs of congruent angles. So the way we do this is I'm going to start with angle T is congruent to angle Z. Angle R is congruent to angle X, and angle S is congruent to angle Y. Now, we can either look at the image to do that, or remember that when you're listing triangles, order matters. So R is in the same placement as X, so I know that R and X are congruent. S is in the same placement as Y, so I know S and Y are congruent. And T is in the same placement as Z, so I know T and Z are congruent. Part C, write the ratios of the corresponding side lengths in a statement of proportionality. Now, the statement of proportionality is just all of the side lengths. So we already started with 12 over 20. But that's equal to my other sides. So we still have 18 matches 30. And then our last one is 15 and 25. Now, right there is your statement of proportionality. But I really like to take that one step further and simplify so that I know that it actually checks out. So if you simplify 12 over 20, you get 3/5. If you simplify 18 over 30, let's see, we could divide by 6. You get 3/5. And if you simplify 15 over 25 by 5, you're going to get 3/5. So the statement of proportionality is just the unsimplified side lengths. But then if you take it one step further, you actually get your scale factor.